You guys will know the answer this time.
All right, so today is 131, creating and graphing linear equations. And I want to just start with a question and see how good your guys' trivia is, because you've never heard this question before. How many people do you think work in the Empire State Building?
15,000.
How the heck did you know? How did you know?
I know my stuff.
You know your stuff.
And that's very random stuff. Okay, and so we're going to put that. Now, what would happen? How long would it take if you only had, say, 2 elevators in the Empire State Building? How long would it take for the 15,000 people to get to their offices?
An hour.
Even more. Maybe if it fills, you can put 20 people in the elevator. So maybe like in 1 minute, you could probably get 50 people, 80 people in there maybe. It would take hours, right? You'd go and you'd line up for the elevator, and it'd be lunchtime. You'd take your lunch in the line, and then you would get on the elevator, go up, and then it'd be time to go home. Right? So what is the remedy for this? Does anybody know about? The Empire State Building has a lot of what? Elevators and floors. So it isn't just like one elevator down here. It's dozens. It's dozens. So here's how it would work. If you were, say, working on the 4th floor, you'd have an elevator for your entire business office. Okay. So maybe in your office there's 100 people that work there, right? You go up the elevator to, transnational corporation, and you can enter into your office right there. Okay. So I'm just reminding you, if you already know how to graph linear equations, that's great. This is really like step 0, just trying to get you acquainted with this. Okay. Now, if I worked right here, which elevator would I go on? 3, okay? So you can see this is also a coordinate grid. So this right here would be at 3 for the elevator. That's my x value. 3 over for x, and then how far up do I go? 4. You guys see? That would be the point, 3, 4. Okay. So we know that. Now, I want to first, before we graph 2 variables, I want to look at 1 variable. So if I'm talking about x is equal to 2, am I talking about an elevator or a floor? X is equal to 2. Tell your neighbor real quick, am I talking about an elevator or a floor if I have x is equal to 2? Elevator. Right? Okay, let's see. Kaylin, what did you and your partner say? Elevator. Elevator. I'm talking about this right here, right? The second elevator. Second elevator. So this is key. When we have y or x is equal to 2, we have a vertical line. Vertical. Add this to your notes. Vertical line. So watch. X is equal to 2 is this line. Because at every floor, right? If I work on the 1st floor, what elevator did I take? 2, right? If I work in this office here. If I work in this office, which elevator? 2. So x is equal to 2 is correct for all of the points up and down. Okay? So we have a vertical line when we have x equal to 2. How about y is equal to 4? What is that talking about? Elevator or floor? Floor. You're going to work on what floor? 4th floor. You must work here. So this line, I want you to have this line on there. Mark that y is equal to 4. Okay? And for the black line we have here, x is equal to 2. I just want you to be able to see that y is equal to some value is going to be a horizontal line. Horizontal line. Side to side. Okay. That's just going to help us conceptualize it. If you're confused, you always know that the point goes x, y, so 3, 4, that's if you're in this office. Now, we're going to have to graph 2 variables, and before I get into this, I want you to look at Desmos up here. If you look at Desmos, let me see if this works, actually. I don't think it's going to, but let's see. All right, I'll zoom in. There we go. All right, here we go. So looking at this, you can see up here we have our y is equal to mx plus b. Raise your hand if you've seen this formula right here. Have you seen this formula? So not everybody. Okay, not everybody. Mostly everybody. Now, when you do Desmos, use Desmos, you see how m
Right now it's m is equal to 1. B is equal to 0. You see we can play it. We can move and change the value for m, change the value for b. So right now, if you are walking from left to right, you're walking from left to right. Moving from left to right. We always look from left to right. Are you walking uphill or downhill? Uphill. So would you say the slope is positive or negative?
Positive.
Positive. If you're walking uphill, you know, it could be a grade, a slope, an angle, an incline, right? So I look at it this way. It's going up into the right. If I'm walking from left to right, I'm walking uphill, right? Now, what do you think I have to do? Well, I'll ask first. Let's do this. So we're walking uphill, right? What do you think I need to change in order for the line, instead of it being here, I want it to be up here? Tell your neighbor, how do we get this line to move up so that it goes through at 5 instead of going through at 0? What do I need to do? Tell your neighbor, what do I need to do to get it to be right here where the laser is? Where it goes through the y-axis at 5. Okay, if you don't see it, we're going to do it now. Okay, so who has one for a mixed starburst? Who has one? Isabel, that was quick. The B. Good. What is our B value if we look up here on the notes? It's our y-intercept. So watch what happens. I'm going to go ahead and change the B value right here. I'm going to change it to 5. Let's see what happens. What do? We just moved it up. Remote.
That's cool.
Yeah. How will I get it down here to -3? What do I need to do? Change it down to -3. You see how it moves up and down based on what my B value is. What my B value out here. Because essentially you're multiplying x by something, then you're adding B. So the y value has B added to it. Okay, so let's get it back to 0. Let's get back to 0. And essentially when we have 0, then we'd have y is equal to mx plus 0. So y is equal to mx when b is 0. Then it's going to go through 0. All right, how am I going to tell your neighbor, how am I going to, instead of walking uphill with a positive slope, so right now I'm walking uphill with a positive slope, how am I going to change it so I'm walking downhill? Tell your neighbor, how am I going to make it downhill? All right. Let's see. Genevieve. Change the slope to a negative. Perfect. And as we're moving through the negative, if you were walking on a slope that's 0, how hard is it to walk on a slope of 0? It's very hard. What do we have when it's a slope of 0? Flat line, right? Okay, so we're just talking about the angle of it. Watch, when I get to 0, watch what happens. Flat line, right? Walking uphill, and then walking downhill. Look what happened when I am. Put a -2. That one's really steep, right? That'd be hard to, I mean, I usually use like riding a skateboard, but that might be like midway through like a pipe. Half pipe, maybe. Okay. Now, let me bring it back. Over here. All right. Is this very steep right now? Could you walk up that?
Yeah.
Okay. What if you're rock climbing? I want you to tell somebody, well, I'm going to do this. Let me put it right here first. See how it's 1? So that slope right here is a rise of 1, a run of 1. A rise of 1, a run of 1. Let's look. Rise of 1, run of 1. Right? Rise of 1, run of 1. Sorry. Rise of 1, run of 1. So it is always the same slope. Okay? Give me a slope. I want you to tell your partner, what would a slope be for if you had to rock climb? You can no longer walk up it. You had to have rock climbing shoes. You got to have your belay device, all that stuff ready. Tell your neighbor, what slope do you think we'd have to have in order for you to have to like start rock climbing? Think of the slope. It's the rise over the run. Rise over the run. So I need some logic for the starburst this time. Give me some logic. Yeah. You got it.
I mean, bigger than all this stuff.
Good. All right, Joseph, help us out. What do you think our slope should be for rock climbing? 5/1. I like that. So it's a rise of 5. You go up 5 feet for every foot you go over. Okay? And I think that would be pretty hard to walk up. So let's see. If it was 5/1, what am I going to put for my m if it's 5/1? 5. Let's see if we got it. 5. Does that look like you probably need some? You need some belay device. You might need some safety or top rope. Okay. Good. What were you going to say back here? Barry, to give you candy.
Waiting patiently.
What was your guys' slope?
We 7.
Okay, so we're going. This is like at least a 9B right here. 7. Yeah, that's steeper. That's steeper. How about if you had to do an overhang? You know what an overhang is? Know what an overhang is? So you're climbing, you're climbing, you're climbing. You want to get to the top, but look, there's an overhang. You got to get over the overhang. This is the overhang. So I want you to tell your neighbor, what do you think my slope would be if I was climbing? Oops. Let me do it slightly different. How about if it was this way? Let's see, you're going up, and then there's an overhang, and then you can keep climbing up. This is the hardest part because what? You can't really use your feet as much unless you're like grabbing with your toe, the top of your toes. So tell your neighbor, what is the slope going to be right here, right there? So you're climbing up like this. So try to remember, is it positive or negative, and then maybe give it a slope. Magnolia, what did you guys discover? Okay, and how would we express that? If it's positive divided by negative, what's it going to be? Negative. So all in all, if I was using this, I think you'd be totally correct. But we usually assign the negative to the numerator on top. So just keep that in mind. So you're saying that that would be approximately the overhang? Yeah, that's pretty close. Maybe it's a little less steep inverted like that. But this would be like you're trying to climb up this side over here. Negative slope because you're going downhill from left to right. You guys acquainted now with, you guys remember all the graphing parts? A lot of it we just covered. Caden, the question. Who had a hand up right here? Did it go up and down? Okay, figured it. Okay, so I'm going to leave this right here, and we're going to just look at the rest over on the other, yes, I will turn that off. The other board here. All right. Transitioning. Making people at home all sick. All right, back to 1, and we're back. Okay, so back to this board, and we just have to graph it now. I think we're pretty good with this. So first off, we always start with graph that y-intercept.
Okay.
This right here?
Yeah, that's the y.
What does it be? Never mind.
Yeah.
Want to hear my joke?
I knew what to start with, I just called it the wrong thing.
Oh, I was going to do a joke, but did you know what it was going to be?
Joe Mom.
Not a Joe Mama joke. I don't want to. All right, so we have to graph the y-intercept. Where am I going to graph my y-intercept here?
-2.
Negative 2. 1, 2. Graph. -2. That's my first one. -2. How hard is that? Easy. You look for that number that's off by itself, the constant by itself, and that tells me my y-intercept. Okay. Next step. Use the slope to find the next point. Go ahead and use the slope to find the next point. Go ahead and do the rise over the run. These are both positive values, so I know I'm going up to the right is the positives. To the right are the positives. Okay, check with your neighbor. Do you have it? Do you not have it? Okay, let's see. All right, Kim, help me out. What is my slope first off? 2 over 3. So from this point, what do I need to do? What do I need to do? Good. 1, 2. 1, 2, 3. Right here. You see the step I made?
Wait.
I don't see any negatives here at all.
Oh, I'm looking at the wrong problem.
Okay. This is negative 2/3. I think that's maybe a little tricky because I was talking about 2 and 3. We're up here though, so it's all positive. Okay. You guys see that this is like a step right here? Maybe with a different color, it's easier to see. This is a step. Can I graph my line with 2 points? I can.
Yeah.
Let's just see if this holds true. If I wanted to go up to my next point, how far up would I go? 1, 2.
Over 3.
1, 2, 3. There's my other step. Have you ever walked on a set of stairs that had different slopes? Maybe if you were like backpacking, it was like, has anybody ever been to Yosemite? You ever done the Vernal Falls Trail, all the steps?
I don't know.
So those steps aren't perfect, right? You'd remember it's like 1,000 steps.
Well, I mean, I went when I was like 7 or something.
Oh, really?
I just went this summer.
Okay, cool. So it's usually misty. It's called the mist trail. There's always water kind of misting off the waterfalls. But that's the only place where you see like steps like this, and a step like that, and a little step. That doesn't happen unless you're like backpacking, right? So what I'm trying to point out is, or hiking, when we are graphing these points, the steps are always the same, and that allows us to have a straight line. Graphing a line, easy? Yeah, okay. So I want you to be really confident because we have to do they're basic, but we have to do a couple word problems with this. And the only thing we need to figure out is, what is my B and what is my M? And they're going to give you that info. All right, let's go ahead and graph this. You guys go and graph it start to finish. Go ahead and do it. Graph that start to finish. And then check with your neighbor, please. Okay. All right, y-intercept is 3. Where are we going to put it? 1, 2, 3. Next step.
Down 2.
I like the cadence of that. Down 2. 1, 2, and
Over 3.
down 2 over 3. Right there. If I wanted to do more steps, could I do more steps?
Yes.
Yes.
Is it necessary?
No.
No, because between 2 points, you can make a line. It's kind of a basic definition here. So we could keep going, and we'd see that each step would get us right back onto the line. But you don't need to show as many steps as that. Okay, we got our line. Just put arrows showing that it goes forever. Thumbs up, sideways down for just graphing basic equations. Good, good, good. Okay, this is kind of a review, first part of the lesson. Next. Let's look at this problem. We're going to have to do some word problems. It is not as tricky as it seems. I'm going to do a couple of them with you in the workbook to start. But if I look at this, when I'm trying to figure out, the only thing we have to figure out for this is what goes in for my M, question mark, what goes in for my B. Now, what is the difference? Tell me one difference between M and B. Yes, Evelyn. B happens once, right? The B value, so like if you get into a taxi, remember this kind of example? You pay $2.50 just to get in. And then what else do you pay? Each what? Each mile you pay something else. So you can see that $2.50 to get in the cab, that's our B value. In this case, if you pay 50 cents a mile, it'd be 0.5 times X. Okay, so this is just kind of conceptualizing. So we need to just figure out, are there any other examples, reasons why M and B, that information looks different? It's actually trickier because I just said it, but maybe there's another thing to think of. What do you think? I will leave it. Yeah,
Isn't the n, don't you have to multiply by n?
that's it. That's perfect. We've multiplied by X. So that tells you right now it's a variable quantity. This amount is going to change, right? If you drive 20 miles, 50 cents a mile, you're going to pay that $10. That's a rate that could change based on how far you go. Okay. So from this information, I want you to decide what is my M, what is my B. Essentially, as I'm setting this up, I am just going to be entering something for my M, something for my B, and that will allow me to simplify and have my equation and graph it. So read that problem up here. Selling used cars, you make $200 per day and $50 per car sold. Create an equation based on that input. Okay. All right, and then tell your neighbor which one's which. What do you think?
230. And then after 200,
Wait. Yeah.
All right, that's good. I'm calling someone I don't usually call on, like someone I don't. Yeah. Okay, Anna, help us out. What do you think is what?
For M, I put 200, and for B, I did 50.
Hey. Well, one thing I think that Leah just said is that this is going to be a variable quantity. Because based on what my X value is, this quantity, this amount, is going to change, right? So what if I had a crazy day and I sold 50 cars? $50 per car, I would have made $2,500 in one day. Plus $200. The $200 is how much you're just paid per day. Okay. So if you didn't sell any cars, how much do you make that day?
200.
$200. The $200 is just what you're paid. It's like your salary. Okay, so we're actually going to switch that around. This is B, $200. M is $50. Because if it's $50 per car sold, that would change. What if I sold 10 cars?
You get like $500.
Plus 200?
700.
700 altogether. Okay? So does that make a little bit more sense in that way? Okay, so I want you to think anytime they give you a problem like this, and it's something where it's like $50 per car, think about it and put it in there like, well, what if I sold no cars? I sold 0 cars. Just $200. That might help you putting it and phrasing it like that to see $200 is the thing that is what do we call it when it doesn't change? Constant. That's our constant amount we're going to earn, we're going to pay, whatever it is. All right, let's open the workbook actually. We're going to do number 3 together. Okay. No, let's do number 4 together. No, let's do number 5 together. It's on page 65. So you have numbers 1 through 10. And I'm going to give you about 15 minutes to work on it. We'll finish this in like a minute. Okay, everybody's looking at number 5. This is 65, page 65 in the workbook. And let's all look at number 5. Everyone go ahead and read number 5 on your own. And then I'll give you a question for the next step. Everybody read number 5 on page 65. Page 65. And I don't mind if you do this problem with us together, so you can. This can be at the top of the page. I don't really care if the numbers are in order. Occasionally. Okay, everyone ready? And now talk with your neighbor. We can move on if we have 100% here. Talk with their neighbor. What is my M? What is my B? Fill in this. Good. All right, Marcus, what'd you guys come up with? $2.50. So you get into the, okay, so if you read the problem, it says what, 40 cents per what? Per mile driven. So anytime it says like 40 cents per mile, that gives me an idea that it's a variable quantity. Because think about it logically, it could be that I go 10 miles. It would be $4. I can go 0 miles. How much would I be paying once I get into the cab? $2.50. You're paying $2.50 no matter what. That's how a cab would work. You get in, you pay that basic, and then they charge you for every mile further. So let's make this into an equation. Y is equal to, I'm going to leave this like this. 4/10. How do we graph 4/10 on a graph? Let's try to make that into a fraction. How could I make 4/10 into a fraction? Tell your neighbor. 4/10 as a fraction. 4/10. 4/10 is what? What fraction? You see it? It's even in the phrase. If you say it, this is 4/10. It's in the tenths place. So it would be 4/10. Could we reduce that? You can make your slope. You could take 4 steps up and 10 steps over, or you could take 2 steps up and 5 steps over. Okay, these are equivalent. I just reduced it, dividing by 2. Okay. So I'm going to go and put this as 2/5, because this is our 0.4 or 4/10, right? I just reduced it. Okay. Is it pretty, you only have 2 things to choose, right? Your B and your M. And then you can make an equation. I think you guys can graph this pretty straightforward. Let's see. Where do I put my y-intercept? 2.5. And then what do I need to do? Up to. So I'm going to go up to 3.5, 4.5, and then 1, 2, 3, 4, 5. Ugh, get even in the way here. It's approximately, right? Don't do your work like this. I ran out of whiteboard space, but make sure it's a little neater. Okay. Thumbs up, sideways, down for the basic word problems. Graphing, good. Need a little work? Okay. So you got 1 problem done. You got 9 more. Should we remind anybody at home what we're hoping for? What our life has? 250. Wins a Kit Kat? Okay. How about win a Kit Kat on 3? 1, 2, 3.
Win a Kit Kat!
By subscribing on 3. 1, 2, 3.